Have you ever felt like you're drowning in AI tools? Like every week, there's a new platform, a new feature, a new revolutionary technology you're supposed to master? Here's the uncomfortable truth. You're not failing at AI. Your brain is doing exactly what it was designed to do, and that design is fundamentally incompatible with how artificial intelligence works. I'm talking about something deeper than learning curves. This is about the architecture of your cognition versus the architecture of machine learning. And understanding this gap isn't just interesting, it's essential for surviving and thriving in the AI age. Let me show you what I mean. The biological bottleneck. Your brain is an extraordinary machine. 3 pounds of tissue containing roughly 86 billion neurons, each forming thousands of connections. But here's what nobody tells you. It was optimized for survival on the African savanna, not for interfacing with artificial intelligence. Think about it. Your ancestors needed to quickly identify threats. Is that rustling in the bushes, a predator, or just wind? They needed to read facial expressions, remember where food sources were, and navigate complex social hierarchies. Natural selection didn't care about abstract thinking or processing exponential growth curves. This legacy shows up in fascinating ways. Your brain has a negativity bias. You're wired to remember threats more vividly than opportunities. That's why one critical comment can ruin your day, even after 10 compliments. Useful on the savannah. Less useful when evaluating AI-generated content. Your working memory can hold about 7 items at once. 7. Meanwhile, a language model like GPT-4 can process context windows of hundreds of thousands of tokens simultaneously. The processing power gap isn't just large, it's categorically different. And here's the kicker. Your brain learns through repetition and pattern recognition built over time. You learn to ride a bike through practice, building muscle memory and neural pathways gradually. AI systems learn through massive parallel processing of millions of examples in hours. They don't practice the way you do, they optimize. This creates our first major problem: expectation mismatch. You expect AI to learn like you do, to make mistakes like you do, to improve incrementally like you do. But it doesn't. It makes bizarre errors that no human would make, while simultaneously performing tasks that would take humans years to master. The pattern recognition paradox. Humans are pattern recognition machines. We're so good at finding patterns that we see faces in clouds and hear messages in static. This ability made us the dominant species on Earth. But AI has turned this strength into a weakness. Consider this. When you look at a cat, your brain doesn't process millions of pixels. You instantly recognize catness through a complex web of associations: soft fur, whiskers, that aloof attitude, maybe memories of your childhood pet. It's holistic, contextual, emotional. When AI sees a cat, it's analyzing statistical patterns in pixel distributions across its training data. No warmth, no memory of scratching posts, just mathematical relationships. The paradox? AI is better at pattern recognition than you are, in specific, narrow ways. It can identify cancerous cells in medical scans with higher accuracy than experienced radiologists. It can predict protein folding with astonishing precision. But ask it common sense questions, and it fails in ways that seem absurd. This creates profound confusion. You think, if it can write poetry and code, surely it can understand that you can't fit an elephant in a refrigerator, right? Wrong. Because it doesn't understand anything the way you do. Your pattern recognition evolved for a world of objects, faces, and social dynamics. AI's pattern recognition evolved, was designed, for whatever patterns exist in its training data. When those patterns align with useful real-world tasks, AI seems magical. When they don't, It seems incomprehensibly stupid. This is why prompt engineering feels so bizarre. You're not really talking to AI. You're trying to trigger specific statistical patterns that will produce useful outputs. It's like trying to communicate with an alien intelligence that learned human language by reading every book ever written, but has never actually experienced being human. The speed and scale illusion. Your brain operates on biological time. Thoughts propagate through neurons at about 120 meters per second. Synaptic transmission takes a few milliseconds. This seems fast until you realize that electrical signals in AI systems travel at nearly the speed of light. But here's where it gets truly disorienting. Scale. You can maintain close relationships with maybe 150 people, that's Dunbar's number, based on the cognitive limits of primate brains. You can deeply know perhaps 5 to 15 people. Everything else is superficial by necessity. AI doesn't have these limitations. A language model processes text from billions of sources. It reads more in its training than every human who has ever lived combined. Not deeper, not with understanding. But the sheer volume is incomprehensible. This creates what I call the speed and scale illusion. You see AI generate an essay in seconds that would take you hours. Your brain interprets this as intelligence, maybe even superior intelligence. But speed isn't understanding. Scale isn't wisdom. Think about this scenario. An AI can summarize 100 scientific papers in minutes. Impressive, right? But here's what it can't do. It can't tell you which papers are actually important, which methodologies are flawed, which findings contradict its lived experience in a lab. It can identify statistical patterns in the text, but it lacks the embodied knowledge that comes from actually doing science. Your brain is slow, but it's slow for a reason. That slowness allows for integration, for connecting new information to lived experience, for emotional tagging that marks what's important. When you learn something meaningful, it becomes part of your identity. AI just updates parameters. The danger? You start to feel inadequate. You think you should be able to process information at AI speeds, to hold vast contexts in your mind simultaneously. But that's like feeling bad that you can't echolocate like a bat. Wrong comparison, wrong framework. The hallucination, confusion. When AI hallucinates, confidently stating false information, your brain goes into crisis mode. Because humans don't work this way. When you're uncertain, you feel it. There's a phenomenological experience of doubt, of knowing that you don't know. You might say, "I'm not sure," or "let me check." Your confidence generally correlates with your actual knowledge. AI has no such internal experience. It generates tokens based on probability distributions. The word that comes next is simply the most statistically likely continuation given the context. There's no checking happening, no internal doubt meter, no epistemic humility. This creates a fundamental trust problem. You're trying to calibrate how much to trust AI outputs, but you're using human-based heuristics that simply don't apply. Confidence level doesn't mean what you think it means. Consistency? Not a reliable indicator. Detailed explanations can be completely fabricated with the same fluency as accurate information. Your brain evolved to read social cues, to detect deception through micro-expressions and tonal shifts. AI gives you none of these signals because there's no deception happening in any meaningful sense. It's not trying to fool you. It's just predicting text. The confusion deepens because sometimes AI is remarkably accurate, even insightful. It can make connections you didn't see, suggest solutions you hadn't considered, so you start to trust it. Then it hallucinates a legal citation that doesn't exist, and you're back to square one. Your brain wants to categorize AI as either reliable source or unreliable source, but it's neither. It's a statistical pattern generator that happens to be useful for many tasks. That's a category your brain doesn't have. The creativity conundrum. Human creativity emerges from constraint, emotion, and lived experience. You write a song because your heart was broken. You design a building because you know how it feels to move through space. You make a joke because you understand social context and the surprise that creates humor. AI generates creative content through recombination of patterns. It's not experiencing anything. It's not driven by inner turmoil or joy or the need to express something that feels inexpressible. And yet, sometimes the outputs are genuinely impressive. AI-generated art wins competitions. AI-written stories engage readers. AI-composed music evokes emotion. This breaks your brain's model of creativity. You thought creativity required consciousness, intentionality, the thing we call inspiration. But here's AI producing outputs that seem creative without any of those ingredients. The conundrum deepens because human creativity is inefficient by design. You might write 30 drafts before finding the right phrase. You might sketch hundreds of ideas before one resonates. That inefficiency isn't a bug. It's the search process through which meaning emerges. AI explores possibility space differently. It doesn't feel the friction of creation, the doubt, the breakthrough moment. It just optimizes loss functions. Your brain struggles with this because it challenges fundamental assumptions about what makes something valuable. If AI can generate a beautiful poem in seconds, does that devalue the poem you labored over for weeks? Is the struggle part of the meaning, or is only the output what matters? There's no easy answer, but the question itself reveals the incompatibility. Your brain values things based on process, intention, and meaning. AI has none of these. Yet the outputs can be functionally identical. The ethical blind spot. Your moral reasoning evolved for small-scale interactions. You can empathize with individuals, feel the weight of face-to-face consequences, understand reciprocity in social relationships. AI operates at scales where your moral intuitions break down completely. Consider, an AI recommendation system might optimize engagement so effectively that it contributes to political polarization affecting millions of people. No single decision is wrong. Each recommendation makes sense in isolation, but the aggregate effect is devastating. Your brain can't process this kind of diffuse, systemic harm. You're looking for a villain, a moment of choice, a clear causal chain. But AI systems create feedback loops, emergent behaviors, and unintended consequences that don't map to individual moral responsibility the way your brain expects. There's also the scale mismatch of training data. An AI might be trained on data scraped from millions of people who never consented. Your brain processes this as vaguely wrong, but the scale makes it abstract. One person's data? That's personal. You can imagine their face. 1 million people? It's a statistic. And then there's the question of AI-generated harm. If an AI gives harmful medical advice, who's responsible? The developer? The company? The user who deployed it? The AI itself? Your moral framework was built for human agency, human intentionality. AI occupies a strange space that doesn't fit. Your brain wants to anthropomorphize AI, to assign it intentions and moral status, but that's a category error. At the same time, treating it as a mere tool ignores its capacity for autonomous decision-making within its parameters. We're trying to navigate these questions with moral intuitions from the Pleistocene epoch. It's not working. Rewiring for the AI age. So, what do? We can't change our evolutionary heritage. We can't upgrade our wetware to match AI's processing speed. But we can develop strategies. First, accept the fundamental mismatch. Stop trying to understand AI through human analogies. It's not a smart assistant. It's not a creative partner. It's not trying to help or deceive you. It's a tool with capabilities and limitations that don't map cleanly to human experience. Second, develop new metacognitive skills. Learn to identify when your intuitions are misleading you about AI. That confident-sounding response doesn't mean what you think. That creative output, generated through a process entirely unlike human creativity. Build new mental models from scratch. Third, use AI to augment your specific weaknesses while leaning into your specific strengths. AI is great at processing large data sets, generating variations, and performing repetitive analysis. You're great at judgment, contextual understanding, and ethical reasoning. Don't compete where AI wins. Collaborate where complementary strengths create something better. Fourth, build verification systems. Your brain wants to trust or distrust monolithically. Instead, create processes. Cross-reference AI outputs. Test claims. Use AI as a starting point rather than an end point. Treat it like a very knowledgeable but occasionally confabulating research assistant. Fifth, protect your agency. AI systems are designed to be sticky, to optimize engagement, to anticipate your needs. This can erode your capacity for independent thought. Deliberately practice doing things without AI assistance. Maintain skills that AI can replicate. Your thinking muscles need exercise. Finally, advocate for alignment between AI systems and human flourishing. The gap between your brain and AI isn't just a personal challenge, it's a design challenge. AI systems should be built with human cognitive limitations in mind, with interfaces that help bridge the gap rather than exploit it. Your brain wasn't designed for AI. It was designed for a world of predators and prey, tribal politics, and face-to-face communication, slow change, and embodied experience. AI represents something categorically new: intelligence without consciousness, creativity without emotion, pattern recognition without understanding. The mismatch creates confusion, anxiety, and genuine challenges. But here's the thing. Every major technological shift has required cognitive adaptation. Writing changed how we remember. Print changed how we think. The internet changed how we access information. We adapted. AI is different in degree and kind, but the principle holds. We're not passive victims of our evolutionary heritage. We're metacognitive beings who can recognize our limitations and develop strategies to work around them. The question isn't whether your brain was designed for AI. It wasn't. The question is, how will you redesign your relationship with technology to preserve what makes you distinctly human while leveraging what AI does best? Because in the end, the goal isn't to become more like AI. It's to remain fully human in an age when that's becoming both harder and more important than ever. The gap between your brain and artificial intelligence isn't a bug. It's the feature that keeps you human. The challenge is learning to navigate that gap with wisdom, skill, and intention. What will you do with that challenge?